Hello, hello, welcome back. We continue to review the textbook, and the name is Understanding Construction Drawings. This video is about Unit 35, and that is all about fire-rated and acoustical considerations. So this is important and we'll be able to identify and explain the construction of fire-rated walls and find and interpret detailed information on acoustical considerations in walls, floors, and ceilings. So this textbook is reviewing the multifamily buildings, and usually the multifamily buildings are constructed the same way as single family buildings. In most jurisdictions, a wall that is shared by two living units in a multifamily structure is called a party wall or common wall. In addition to the usual requirements of a wall, a party wall requires more fire resistance and sound privacy. When two living units are separated by floor and ceiling, that construction needs to provide the same protection a party wall should provide. Let's take a look at the fire-rated construction. It serves two purposes in the event of a fire. It slows the spread of fire and it maintains structural support longer than non-fire rated construction. Approved fire caulking or fill must be used at all utility line or fire rated wall penetrations. The most obvious way in which a wall, floor, ceiling, or roof can slow the spread of fire is by having a fire-resistant surface. Plaster and gypsum wallboard are fire-resistant materials. They do not burn, they do not easily transmit the heat of fire to the framing members on the other side. Unfortunately, standard gypsum wallboard breaks down and crumbles in very high heat, and fire-rated wallboard is used where a fire-rated wall is required. And it is usually gypsum board type X or type C. Varying degrees of fire resistance can be achieved by using a second layer of fire-rated drywall on one or both sides of the wall. Other materials such as OSB that has been treated to resist the spread of fire might be used in place of gypsum wallboard. And again, refer back to the textbook. You can see the wall section showing actually the wall sandwich. Fire-rated construction is frequently used to separate garages and mechanical rooms from living spaces. Party walls are also fire-rated to prevent a fire from spreading between housing units. To completely separate the housing units, a fire-rated party wall should extend all the way from the foundation to the structural deck or the roof above. Most building codes allow an alternative to extending the party wall through the roof. The fire-rated construction may end at the bottom of the roof as long as the roof is of fire-rated construction. And this usually means that the roofing material resists fire for as long as the party wall does. And for example, if the party wall is required to be a 1 hour code wall, the roof must be covered only with the material that also resists fire for 1 hour. Fire-rated walls must also prevent fire from spreading vertically inside the wall, and if left open, the spaces between the studs, the stud cavity, will act like chimneys, allowing flame to spread very quickly from one level to another. To prevent vertical flame spread, stud spaces are not permitted to be more than 10 feet high. So the spaces between the studs are closed off with fire stops at each level. And instead of wood fire stops, the wall cavity can be blocked off with fire-resistant fiberglass insulation as well. So openings are usually avoided in fire-rated walls, and where it is necessary to include a door, it is made of fire-resistant material as well. The fire rating of the door must comply with the building code, and doors in fire-rated walls are equipped with a self-closing mechanism. And you can learn more about the hardware in the unit where we discuss doors and windows. So let's talk a little bit about sound control in walls. So in order to provide privacy between the housing units, common walls and floors should not allow the sound from one unit to be heard in the next unit. The measurement of the capability of a building element to reduce the passage of sound, it's called sound transmission classification, or STC. So the word acoustic is often used when talking about sound control. It simply means having to do with sound or hearing. Sound is transmitted by vibrations in any material, solid, liquid, or gas. And in order to slow the passage of sound, a party wall must reduce the flow of vibrations. The materials used in the construction of most walls vibrate relatively well, and also they transmit these vibrations to the air inside the wall. Sound can bend around corners and find its way through the smallest of openings. The air carries the sound to the other side of the wall, where it's transmitted to the air on the opposite side of the wall. So the drywall joint between the wall and the ceiling may require sound deadening putty to prevent sound for passing through that joint. The electrical installer may be required to utilize acoustical insulation or some other sound attenuation material around flash device boxes. Raceways may require installations that reduce sound transmission, such as expansion joints, flexible raceways, or raceway offsetting through the party wall. The STC rating of a wall can be improved greatly by not allowing the studs to contact both surfaces. This may be accomplished in one of two ways. So one is to attach clips made for sound insulation to the studs and then fasten the wall board to these clips, and the clips absorb the vibrations. And using the clips and sound deadening fiberboard results in an STC rating of 52. So an STC of 45 is achieved without clips by using 2x4 studs and 2x6 plates. The studs are staggered on opposite sides of the wall so that no studs contact both surfaces. And STC can be increased to 49 by including fiberglass insulation in between them. Separating the two sides of the wall framing on separate plates and insulating both sides of the wall cavity yields an even higher STC rating. So, and there are many other products and designs that can be used to control the sound transmission through a wall. And it's essential that those who assemble common walls understand and follow the architect's design. So there could be resilient channels or some other methods, such as like special acoustic insulation, and so on. Let's talk a little bit about sound control in floor and ceiling assemblies. So the principles that I use to stop the flow of sound through walls also apply to the floor and ceiling assembly, but wall construction is different from floor and ceiling construction. That's why some provision must be made to either absorb or block the vibrations that are sound. The IRC requires an STC rating of at least 45 for common walls and for floor and ceiling assemblies. Another type of sound comes into play for floor ceiling assemblies. When a person wearing hard-soled shoes walks across a wood floor, the sound created by the impact of the footsteps can be a real annoyance to those living in the rooms below. And the acoustics industry has devised a rating system for impact noise insulation. So the impact isolation class, or IIC, is a rating of the floor and ceiling assembly's ability to isolate the sound from footfall and other impact sources. The IRC requires an IIC, or impact isolation class, of 45 or more for common floor ceiling assemblies between dwelling units. A 45 IIC rated floor would not be satisfactory to many people, though. A rating of 65 would satisfy most individuals. And we know that there are so many options for floor surface materials, sound deadening products, and sealant materials that it's not possible to list even the most common options here. So please review the manufacturer's materials because they usually provide the sound transmission and the IIC as well. So another little section here is about keynotes. So on large construction projects, the drawings might become very cluttered and confusing, and it's impossible to read. So there can be like multiple places where the same information applies. So to avoid this, we use the keynotes. And keynote is a numbered mark, such as a small rectangle containing a number, and that is placed on the drawing. So a column of notes on the right side of the drawing sheet explains what each of those keynotes means or indicates. So, if you're not familiar with the way it looks, I highly recommend to go back to the textbook and check all the graphical representation, because this is critical for you to learn how to read the drawings. So that was it for Unit 35. Thank you so much for watching. I will see you in Unit 36.